Hey guys, welcome to math today. We can count the same way that we count with our fingers and our toes. Let's count by sliding our beads over. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Well, let's actually do this the say 10 way. 10, 1, 10, 2, 10, 3, 10, 4, 10, 5, 10, 6, 10, 7, 10, 8, 10, 9, 10, 10. Wait, not 10, 10. 2 tens. 2 tens, that's 20, because 20 is 2 tens. 2 tens. 10, 9, 10, 8, 10, 7, 10, 6, 10, 5, 10, 4, 10, 3, 10, 2, 10, 1, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, blast off! Finish our number bonds. We're going to draw lines to connect them. So I see 1, 2, 3, 4 dots. 1 dot, and then 4 and 1, that makes 1, 2, 3, 4, 5. So 4 and 1 are parts of the whole 5. Now what are these numbers down here? 5, 3, and 2. 1, 2, 3, 4, 5. 1, 2, 3, 1, 2. 3 and 2 are parts of 5. Now let's look at this number bond. We have 1, 2, 3, 4, 5. 1, 2, 1, 2, 3. 2 and 3 are parts of 5. And down here, what are these numbers? 1 and 4. 1 and 4 are parts of 5. Now let's look at this doggy. Windsor the puppy has 5 juicy bones. He buried some of them in the yard and put some of them by his dish. How could we split this? Maybe he buried 2 of them and he put 3 of them in his bowl. Or maybe he buried 1 of them and put 4 of them in his bowl. Maybe he buried 3 of them and put 2 of them in his bowl. Or maybe he buried 4 of them and put 1 of them in his bowl. What if he buried all 5 of them and then put 0 in his bowl? No, that doesn't really work for this problem. That makes sense, but we know he put some of them in his bowl. He didn't put 0. That would have been he put none of them in his bowl. Now let's look at these triangles. I see 1, 2, 3, 4 triangles and an empty number bond. How could we split this? Maybe we could split it by color. Let's see, there are 4 altogether, and there are 2 green and 2 blue. How else could we split this? Maybe we could just draw a line in between them and put a square around one of them. Let's see. Now there's 1 inside the square and 3 outside of the square. And if we were to write that as a number sentence, we could write 4 equals 3 plus 1. And if we go back to doing it by color, we'd have 4 equals 2 plus 2. Now, what happens if I put another triangle up here? We have to make a new number bond in a new math sentence. How many green triangles do we have now? 3 green. And how many blues do we have? We still have 2. 2 blue. How many do we have all together? We have 1, 2, 3, 4, 5. 5 is our whole, and 3 and 2 are our parts, so we can do 5 equals 3 plus 2. Now, last but not least, I want to look at this square. Let's count corners on our square. 1, 2, 3, 4. There are 4 corners on the square. 1, 2, 3, 4. And I have 4 little dots at each of the corners. If we were to write this as a number sentence, how would we write that? Let's see, there are 4 altogether, and how should we split this? Maybe by color again. So 4 equals 1, 2, 3 red, and 1 blue. 4 equals 3 plus 1. What if we just split it by which ones are on the left and which ones are on the right? And I'm going to erase these greens because those were just us counting. They're not really there. So let's split it like this. 4 equals 2 on the left and 2 on the right. 4 equals 2 plus 2. Bye, guys.